Good morning, students. I hope you are still enjoying your time and simultaneously try to learn the new things. Good. So in last lecture just we have discussed about terminal voltage, EMF, internal resistance, and what is the formula for the terminal voltage? V is equal to E minus IR, and the current which is passing through the circuit, I is equal to E divided by small r plus capital R. In last lecture we had done this, and today one of the very important topic, that is known as combination of cells. Here we are having the two combination. One is known as series combination, other one is known as parallel combination. So first of all we are going to discuss about series combination. So just we are taking the two cells of EMF E1, of internal resistance R1, connected in series with second cell of EMF E2 with internal resistance R2. So here we are having the 3 points. Point A, the connecting point B, and the last point C. So very first thing, for the first cell, potential difference between A and B, the 2 points A and B. The potential difference between A and B is VA minus VB is equal to E minus IR. From this formula, because cell is in use and in series, same current I is passing through both E1 and E2. So VA minus VB is equal to E1 minus IR1 for the first cell. Similarly, the potential difference between the point B and C, potential difference between the points B and C is VB minus VC, that is E2 minus IR2. Using the same formula, E2 minus IR2, E1 and E2 are the respective EMF of the two cells with their respective internal resistance R1 and R2. Okay. Now we are taking the potential difference between point A and C. The potential difference between points A and C can be taken as VA minus VC. So this can be written as VA minus VB minus here plus VB and minus. There is a small arrangement so that we can write VA minus VB from equation 1 as E1 minus IR1 and VB minus VC is equal to E2 minus IR2. Arranging the terms, E1 plus E2, negative sign common, I, R1 plus R2. So this is to be taken as equation number 3. Third equation. So from equation 1 and 2 we had obtained the equation number 3, which gives the potential difference between A and C. For the equivalent EMF and equivalent internal resistance, so just replacing this, and we are taking a common cell and whose EMF is E equivalent and R equivalent. So again VA minus VC. So VA minus VC is equal to E equivalent minus R equivalent. So by comparing the equation number 3 and equation number 4, what you can write? E equivalent is equal to E1 plus E2, R equivalent is equal to R1 plus R2. So we can say that when you combine the two cells in the series, the resultant EMF increases and becomes E1 plus E2, and internal resistance also increases, becomes R1 plus R2. And for n number of cells, we can write E1 plus E2 up to En, and R equivalent can be taken as R1 plus R2 up to Rn. Okay, so याद रखना students, for series combination, current passing through the each cell will remains the same, equivalent EMF increases as well as equivalent resistance also increases. And this is the basic formula for the terminal voltage. V is equal to E minus IR, where I is equal to E divided by small r plus capital R. So this is the expression for series combination. Now we are going to discuss about parallel combination. So second part is this. Parallel combinations of two cells. So what you have to do, you have to take the two cells, E1 with internal resistance R1, another cell E2 of internal resistance R2 with their EMF E1 R1, E2 R2, and we can say that I1 and I2 be the electric current passing through two different cells, because here the junction is to be there. This point is A, this point is B, and these two currents combine to give I. Circuit is closely looped, and we can say that V is the potential difference between the two ends A and B. So already we know that for first cell, what is the potential difference across A and B? That potential difference V is equal to E1 minus I1 R1. So therefore, what is the value of I1? इधर लेके जाओ, E1 minus V divided by R1. This is for current I. Similarly, for second cell, potential difference across A and B, so V is equal to E2 minus I2 R2. So therefore we can write I2 is equal to V minus E2 divided by R2. So this is the value of I1 and I2. Take equation number 1 and equation number 2. But the current I1 and I2 is passing through first cell and second cell and combine at point A. So you can say that at junction I is equal to I1 plus I2. At junction I is equal to I1 plus I2. By substituting the value of these two equations, so I is equal to V minus E1 upon R1 plus V minus E2 upon R2. Simply substituting the value, now simplify the equations. V by R1 plus V by R2, negative sign common, E1 upon R1 plus E2 upon R2. Now take the LCM, V common, R1 plus R2 upon R1 R2, E1 R2 plus E2 R1 upon R1 R2. Simplification, V common, then taking LCM cross multiplication, R1 plus R2 upon R1 R2 here. Then E1 and E2 are the two different EMF. Cross multiplication, E1 R2 plus E2 R1 upon R1 R2. Now cross multiply, I R1 R2 is equal to V R1 plus R2 minus E1 R2 plus E2 R1. So we have to arrange in terms of terminal voltage, that is in terms of V. So bring this on the left side. So V R1 plus R2 is equal to E1 R2 plus E2 R1 minus I R1 R2. Now what you have to do? Now you have to divide. किससे डिवाइड करेंगे आप? By the help of equation R1 by R2 से आप इसको सिर्फ डिवाइड कर लीजिए, सिंपल. तो V is equal to E1 R2 plus E2 R1 upon R1 plus R2 minus I R1 R2 upon R1 plus R2. Okay dear. So here V is equal to E1 R2 plus E2 R1 upon R1 plus R2 minus I R1 R2 upon R1 plus R2. So chalo again repeating this same point. We are having parallel combination. Here we are having the two cells of EMF E1, EMF E2 with their respective resistance R1 and R2, and I1 and I2 be the electric current passing through the two cells. Okay. So potential difference between the point A and B, V is equal to E1 minus IR1. I1 is equal to E1 minus V upon R1. Similarly, for the second cell, potential difference V is equal to E2 minus IR2 R2, and I2 is equal to E2 minus V upon R2. Then I1 and I2 be the electric current passing, and these two electric current combines at point A and give I. So at junction you can say that I is equal to I1 plus I2. By substituting the value of I1 and I2 in this equation, we get E1 minus V upon R1, E2 minus V upon R2. On simplifying, E1 upon R1 plus E2 upon R1 minus V, 1 upon R1 plus 1 upon R2. Okay, now simplifying the equation, we have to obtain in terms of V is equal to E minus IR. So taking LCM, cross multiplication, rearranging in terms of the V, then V is equal to E1 R2 plus E2 R1 upon R1 plus R2 minus I R1 R2 upon R1 plus R2. And now we have to compare. We have to compare with, चलो जिसको just rub. We have to compare with V is equal to E equivalent minus I R equivalent. So when you compare this equation and this equation, so what we can write, कि E equivalent is equal to E1 R2 plus E2 R1 divided by R1 plus R2, and R equivalent is equal to R1 R2 upon R1 plus R2. Okay, so finally we had obtained the equation E1 R2 plus E2 R1 upon R1 plus R2, and you have to remember this formula very clearly. When you are having the two cells of EMF E1 E2, then the equivalent EMF is E1 R2 plus E2 R1 upon R1 R2, and equivalent resistance is R1 R2 upon R1 plus R2. So when you divide these two equations, E equivalent upon R equivalent, what do you get? R1 R2 cancel हो जाएगा, तो we can write E1 by R1 plus E2 by R2, and for n number of cells, so E equivalent divided by R equivalent is equal to E1 by R1 plus E2 by R2 up to En by Rn. So in this manner we can obtain the equivalent EMF and equivalent internal resistance for the combination of two cells in series and in parallel. In series it is very simple. Resultant equivalent is E1 plus E2. Resultant internal resistance R1 plus R2. But in parallel combination, resultant equivalent EMF is E1 R2 plus E2 R1 upon R1 plus R2, and equivalent internal resistance R1 R2 upon R1 plus R2. If you have any doubt, any question, you can call me, or you directly discuss your difficulties on the WhatsApp also. Okay, dear students.